Hello everyone. Today we are going to explore a fascinating topic, redshift, and how it tells us that the universe is expanding. But first we need to understand a key concept called the Doppler effect. The Doppler effect happens when a wave source moves towards or away from you. For example, say there is a car and there is a siren on it, and there is an observer. Say this is observer A and this is observer B. Now the car is moving in this direction with the siren. Now as this is the the siren will produce sound wave, so the wave is propagating like this. Now as the car is moving towards observer A, what will happen to the waves? We will find that the waves, as it is moving in this directions, the waves are being compressed like this, and as it is going away from observer B, we'll find that the waves are being stretched at the back. So this phenomena of the wave is called Doppler effect. I want to show you an animation on this. See, the car is moving in this direction. So let's see what happens to the waves. I think you can see now, as the car is moving towards observer A, the waves towards observer A is being compressed. That means that the wave is being high pitched. But at the back, the car is moving away from observer B, so at the back the wave is being stretched, so it is becoming lower pitched. So this is what happens according to Doppler effect. So now as this is sound wave, we easily can hear that. Now what will happen if a source of light is moving? Let's say this is the earth, and there is a person from here who is using a telescope, and he is observing the night sky, and there are so many stars here at different distances from the earth, and light wave or electromagnetic waves are coming from the stars. Now we will observe whether the waves are being stretched or it is being compressed. If we can understand that, we will understand whether the source of light or source of wave here is moving away from the earth or it is moving towards the earth. This is what we have to find out. Now for this we need to know what electromagnetic spectrum is. We all know that the stars actually emit electromagnetic waves here. Now we do know that electromagnetic spectrum is a range of all types of electromagnetic waves, from radio waves to gamma rays. So from this electromagnetic spectrum we can easily understand that gamma rays has the highest frequency among all the electromagnetic waves, and radio wave has the lowest frequency. And this is the visible light, where see, blue light has comparatively higher frequency than the red light. So this is what we observe for now. Now let's try to understand what absorption line is. When scientists observed light from distant galaxies using spectrometer, they don't see just a rainbow of light or rainbow of colors. They also see this kind of dark lines there. These dark lines are called absorption lines. These lines show where certain elements like hydrogen have absorbed specific wavelengths of light. How do they absorb specific wavelength? Because for example, say this is a star and this is the cooler atmosphere around the star. Now when the light is coming from the core of the star and the light wave is passing through this cooler atmosphere around the star, some of the wavelength or some of the energy at specific wavelength is absorbed by the hydrogen, because atoms in the cooler atmosphere atmosphere are excited then, because it's very hot at the core and the cooler atmosphere is also getting the heat now. So some of the atoms are excited, so they absorb photons of certain energy. For now you just can understand that there's a relation between energy and frequency. When hydrogen absorb the photon or absorb some of the energy, they actually absorb energy at specific frequency or wavelength. That's why as the energy is already absorbed, we cannot see the light of that specific wavelength or frequency. That's why that black line appears at that significant wavelength or frequency, because this energy is already absorbed by that cooler atmosphere around the star. So when the electromagnetic wave comes to the observer on the earth, what happens? They cannot see the light or energy at these wavelength. That's why this black line appears. Now the thing is, if we observe these electromagnetic spectrum, we'll find that for the sun, this absorption line is here, but nearby galaxy that is a bit more distant from the earth, we find that the same absorption line has been shifted a little bit. Now if we see the electromagnetic spectrum of a little bit more distant galaxy from the earth, we'll find that the absorption line has shifted more. If we see the electromagnetic spectrum for farthest galaxy, we'll find that it has the same absorption line has shifted more, and this shifting is happening towards the red part. So what does that mean? That means you see that the wavelength of a blue light is 400 and wavelength of light at this red end is 700. That means wavelength is more here. Now as I have shown you, say this is the earth and there is an observer over here and the stars are here. He is observing the stars. He will find what? He will find that as the stars are moving, the waves are being stretched. The farthest the star is, the redshift is more. Now what does that mean? Now if you notice the electromagnetic spectrum, or you'll find that 400 wavelength, this is for the blue part, and 700 nanometer wavelength, this is for the red part. That means that red light has more wavelength and blue light has less wavelength. So as the stars are moving, if the stars comes towards the earth, or like if the universe is compressing, they should have come towards each other. So the star, like if the star is coming towards the earth, we would find that the frequency is being higher pitched. That means the frequency will increase and the wavelength will decrease over the period or over the time, and we would find that the shift is now towards the blue line, but we find that in real the shift is being towards the red end. That means the wavelength is increasing. Wavelength is increasing. That means the frequency is decreasing. That means they are stretching. The stars are going away from the earth and they are going away from each other. So that is the thing that defines that, or that determines that the universe is actually expanding.